Let's take a look at some rational expressions. A rational expression is a ratio of two polynomials. So -7 is like a constant polynomial, 4x is another polynomial, and so writing one of those in the numerator and the other in the denominator creates a rational expression. An important thing to remember about rational expressions is that there are sometimes numbers that I can't plug into the expression. Remember, we can never divide by 0. We just can't really make sense of that mathematically. And so for each of these rational expressions, there are some values that have to be excluded. For example, I can't plug in any value for x that makes 4x equal to 0. Of course, 4x equals 0 exactly when x equals 0, because if I divide both sides by 4, I just get x equals 0. So as a result, for this rational expression, I can't plug in the value 0 for x, because it would give me -7 over 4 times 0, but that's just -7 over 0, because anything times 0 is 0, and then that's undefined. And so I can't make sense of the expression. I can't find a number that the expression equals. In a similar way, in the second example, I can't plug the number in for y that makes 3y plus 5 equal to 0. And so if we solve that, if I subtract 5 from both sides, I get 3y equals -5. Dividing both sides by 3 gives me y equals -5 over 3. And so then that becomes the value that I can't plug in for y. Right? I can't plug in -5 over 3 for y, because if I did, I would get the expression 10 over 3 times -5 thirds plus 5, but the 3's then would cancel, because this is the same as 3 over 1, so the 3's would cancel, and I just have -5 plus 5 in the denominator, 10 in the numerator, and so that would be 10 divided by 0, which again doesn't make sense. I can't calculate that. I can't find a number that equals that amount. So that would also be undefined. And finally, in a similar way, for this last expression, there's going to be a problem that the expression is going to be undefined whenever z squared minus z minus 2 equals 0. And so to find the values that don't work in the expression, the values that I can't plug into the expression, I need to solve that equation. Because this is z squared, I can't combine those as like terms, so factoring can help. I'd like to find a pair of factors that multiplies to equal -12 and adds to equal -1. So z minus 2 and z plus 1 might come to mind. And now I can turn this into two simpler equations. Z minus 2 equals 0 and z plus 1 equals 0. Solving each of those, I get two solutions, z equals 2 or z equals -1, and those then would be the two values that I can't plug in for z. If I plug in 2, I get 2 squared minus 2 minus 2. 2 squared is 4, so we would end up with 4 minus 2 minus 2, which equals 0, which would become a problem. We would end up with a 2 up top would give me 10, so I get 10 over 0 again, which is undefined. And if I plugged in -1, I would get a 7 up top, and -1 squared is 1, minus -1 would be +1, is the same as +1, and then minus 2. So again, we'd get 7 over 0, which is undefined. So these two values of z give me 0 in the denominator, and that would be undefined. It is, perfectly okay. Notice, it is perfectly okay for the top to equal 0. So z equals -8 is okay. That doesn't cause problems mathematically. I would get 0 in the numerator of the fraction, -8 plus 8 equals 0, and 64 minus -8 would give me 72, because that would become 64 plus 8, minus 2, so I'd get 70 in the denominator, but 0 over 70 is just equal to 0. So that's okay. I can make sense of having 0 in the numerator of a rational expression. I just can't have 0 in the denominator of a rational expression. 0 in the numerator and something else in the denominator means that the value of the expression is 0. 0 in the denominator is just undefined. I hope you enjoyed the video. Thanks for watching.